Let me share my screen. All right, I think you can see the right screen. All right, hello everyone. Welcome to CakeFest and welcome to this talk about state machines. So we are going to talk about automating processes using such a state machine. Yesterday, I already gave a little bit of an input of an example, how we can actually build that. And today I'm going to show how it's actually used, like a real case example. My name is Mark. Yep, so I'm a core developer for quite some years, and I've been a PHP developer for more than 15 years. And I'm currently working for Spryker Systems. I will explain that in a second. And my main expertise is all the tooling that has to happen in order for our system to produce code, because we are a vendor, a software vendor, so we have to produce a lot of code. And we need a lot of tooling around that. So I'm the tooling expert and the release manager. And because I work with CakePHP, both in my private as well as in my professional life, I contribute already a lot to open source, and I'm always eager to contribute to certain libraries out there. Now about Spryker. So as a software vendor, we ship around about 1,000 packages. So those are what we call modules mainly. And these modules, they build a shop. So you can have several different modules for checkout, for card management, for discount, whatever. So yeah, there's a lot of things that you can configure, and the idea is to keep it in a modular system so you can independently use those whatever you need, and you don't need to have the whole huge package. So, and that's why we're using atomic releasing. We call that atomic releasing in that we have a monorepo internally, so it contains all of those packages, and we have split repositories that contain each module separately. So from a composer perspective, you can then use the split repositories and only the ones that you need. But internally for development, it's easier to have all of them together, because if you want to make a pull request with 1,000 PRs, you can imagine that this is a nightmare. So you want to keep it somehow at least contained. And the atomic releasing releases only what you need. So we don't always make Scherer releases, like 1,000 per day, but we only release specific modules. And they can still be across multiple organizations, multiple pull requests still. And they all form what we call a release group. And one release group will have the overview of everything that you want to ship as one feature together. And so we're doing a lot of releases every day, over 10,000 in the last 5 years. And you can imagine this wouldn't work with at least some tooling and automation on top. So more and more of that has to be implemented in order to just to be able to work with such a huge code base, and like a lot of developers, and there is human error, there is some other things that might have been overlooked. So you want to also validate what you're doing while you're developing that. And that brings us now to the actual topics. In this case, I want to first outline very quickly again, what is a state machine? What is a finite state machine? In one sentence, you can say that each of an item, whatever that might be, can be in exactly one of a finite number of states at any given time. So, you know, like a status on on a user entity. So that user is either still pending because it didn't yet register fully, or he is already in the system, like active, whatever. He can also be banned. So that is one way of defining that. If you have an order state machine, like a more complex workflow, then of course you will have a much more difficult state machine and graph to look at. So in PHP, we mainly want to use that for workflow and for we also want to use it to have less if-else jungle, because if you have more and more of if-elses everywhere in the code and you hack more of them in, like nested and stuff, then you have more bugs. Yeah? So you can reduce the amount of human error if it's very simple to follow the code and to understand what's going on there. And then you want to have a direct link between code and the visual representation. So you can print it out, you can put it on the table or put it on the wall, and even the salespeople or the marketing people or the POs that do not read code usually, they can understand a visual representation. And then you want to use something that is easy to maintain and to grow over time and easy to modify if you need to, even if it's a complex system. Here's an example. This example is out of our state machine. So it's one small blob in the bigger picture. You can see here, and I will probably explain that quick, the terminology. States are these round bubbles. So each of them is that clear finite state that we were talking about. And then each state has a transition to another state. And those are the arrows. And sometimes you have something like a condition in between. This is this route thing in the middle. And a condition means it's a Boolean decision to make, either that or else something else. So to keep things simple, a state machine ideally has always a Boolean decision, and they can be coming after each other, but you should not have such like that many different possibilities for an outcome. Yeah, so conditions to check something and then decide what path to take. We have events. Each of the events here is a bold text. So check split, confirm split, recheck split, validate. Those are events that can be triggered either manually by click of a button somewhere or by an external API. For example, Travis or GitHub can report back, hey, this has been merged, this has been, is green in Travis in the CI system. And that can trigger again an event, which then makes the state machine continue. Yeah, and sometimes you just need buttons. A human needs to verify, hey, I confirmed that this pull request is okay. And, or I have like checked all the dependencies and it's valid. So these kind of things. Yeah, and commands is something that you can see at the very bottom with validate. So here we execute something in PHP. The conditions are checked in PHP. That's the release is split here. But also the commands are something that can be directly connected to PHP code. So conditions and commands we'll talk about later. But all right. One question was there in the chat. Is it bad that I want to implement state machines just to help visualize statuses of different entities? No, I would say you can have also state machines to just do that without having to combine it with code. But I think you will find out over time, if you already have the state machine and the visualization, it is actually not that much anymore to combine it, and you have really a lot of benefits for that. And you will also realize there is some automation probably that you can hook in, or just some verification of the order. So in this case, for example, it would not be possible to have the split complete and the validate executed before the split started has been reached. Yeah, so the human error of someone already releasing something without having merged it, it's not possible with the state machine usually, because it has a clear defined order from what state to transit to another state. And those benefits, I think, are really already valuable, even if you don't automate it just yet. Just first step visualization and drawing it, and the second step combining it already to make it manually working. To show you the actual state machine, it's a Cake 3 or 4 plugin. It's not open source, it's open code. That means it just cannot be open source at this time, but you can use it in your project and you can use it in your current open source or proprietary code. But it has to be protected in a certain way, because it is a very key piece of our business logic. The big brother of it, the official state machine, is actually running in a lot of order management processes in the Spryker framework. And this little brother, this is the CakePHP brother, contains and shares the same code, clearly. It's just a little bit of a different specification, a bit different in terms of the ORM. It uses the Cake ORM, but it still has to be under the open code license. So you can use it, but without any warranty, like liability issues and so on. So can still free use it for you. Let me see if I can show you the code. I think this one is it. The documentation should be quite complete. They contain first the explanation, the terminology of the different words that are used. They have a bit more explanation on certain things. For example, that some events that you might have seen can be automatically transitioning on enter, and others will have a button to press depending on what's going on. Okay, before I go deeper, let's go back to the actual So when we want to create a state machine, usually you already have a use case in mind, I guess. Generically speaking, a configurator of something. It can be like if you want to configure a car and you know all the things that you need and the order that it should have. You can use that. Some way of checkout or special checkout processes can have that. If it's not just a linear process, but a more complex one, then you won't just have steps, but you actually want to have a more complete state machine process behind it, probably. Any way of order management, usually, because including payment processing, shipping, refunding, partial refunds, partial splits of like shipping and stuff. But that is a very complex issue that, usually if you don't use an order management system that has a state machine behind it, you will really end up in a chaos situation. And then you want to connect it with, for example, a queue system, because that really leverages the full potential of a state machine. If you just use it normally, then a human has to do all of those things, or in some cases, the external API systems can trigger things, sure. But there are long-running processes. For example, in our application, we have Composer updates and installs that need to work, and Composer requires sometimes certain other tools that need to run on the code base, and they can take up to 5 minutes. And you don't want to have your application or whatever wait that long. So what you do is you trigger a queue job. The queue job applies this job, and when it's finished successfully, the queue job itself will actually trigger the state machine again. So it will tell the state machine, hey, this is my event that I'm firing now, and do what you want with this. So the state machine usually takes this event, realizes, okay, that means I can continue now because we are at this event. and the state machine continues to run normally. And now to our real-life example. As we said, thousands of repositories with 15 releases per day, which then, those are the release groups. That means each release group can contain, again, up to hundreds or more really releases, also module releases. And so it can be quite a bit per day. And this, like with a human, would, and we did that in the past, of course, but the system was smaller. That now would just take like way too much time. You have different validations and constraints that you need to apply. If you release a major, for example, you need to make sure that all of the versions that depend on this are also either majors, because it's a cascading major, or they need to be allowing patches. So they need to say this new version or the old major version. Yeah? So otherwise you're blocking the system from actually being able to upgrade. And these kind of tools need to run in this real life example. So here you can see in small on the side the actual state machine that we are currently using. And this is still a very simple one. So there are much more complicated ones in the order management processes. But now for our use case, this is what we are using for the release process only. So not for the development, but when you really want to ship something. Yeah, so the workflows, the goals here for us were the clearer workflow, first of all. We don't want to have the human error of someone releasing something before it was fully merged and split into the repositories, in the split repositories. If that happens, it's really painful to take something back, and also human error prone. So you don't want to do that. The workflow should be clear. And at the beginning, this was just it. You just had then a human click buttons all day long. Yeah, so you just click buttons. Once this was finished, you click the next button and the next button. So this was already better than before, doing everything just by some documentation and manually. But still, you need to wait almost up to half an hour for each of those releases to go through. And you were just sitting and waiting and clicking. So we wanted to have more automated workflows. And here we just added these transitions where when an event is fired and it can actually continue to start another Queue background process to do some calculation or some composer install and updates, then you do that and so and so. And only if something goes wrong, you need to actually intervene. So then we get an alert in our system in the Slack channel. And then in that case, we are going to intervene and say, hey, yeah, this is an edge case. I can manually click, okay, this is fine, whatever. So more and more validation is added automatically, but sometimes you still need a little bit of manual validation on top as well. Before let me go back if I can. I want to now go into the actual code just so that you can see something, because that's always cooler, I guess. So this is the release app. This is our internal CakePHP application that yeah, manages the whole release process. We can see the modules with, for example, some have like a lot of versions, and each of those versions then have their own API, what they expose, and we need to verify all of these things together with the other versions. We have all the pull requests. The most important or interesting part is now the release plan. So as I said early at the beginning, we want to group everything by release groups. So each pull request for one feature is grouped together, and usually you can have 2, 3, or 4. In this case, we have 1 in the release plan. So that already went from draft to review to the ready to release state. And here we have 2 pull requests. One is in our main repository and one is the project. The project is needed because sometimes you have project implementations that you need to do in order to allow this change to work. You need to hook it in, you need to extend something on project level. So it's not uncommon that you have more than 1 pull request here. And you can see that we are releasing here a patch and 5 minors. Yeah, the minors are yellow and the patch is blue, red would be a major, but we don't have that in this release. So usually you can see in the dashboard that this is release ready with a high priority. So let's go in. No, the theme here is still Foundation 5. It's very old, and we actually want to upgrade it to Bootstrap 4 or sometimes 5 maybe. Yeah, it just needs time and a lot of resources to upgrade a huge application, especially on the layout part. So this is a very basic layout, the default one that shipped with Cake 3 at the time, I think. Yeah, it will have to be some Bootstrap 4 in the future with more information density on it as well. So here you can see that the validation run was like not green. That's probably because of Travis. So this is something we shouldn't release usually, because Travis should be green. But in this case, I know that it's just a false positive here, and it's not related to this pull request, so it's fine to release this. And therefore, I can actually go into the auto release process. So for this, we can start a state machine. And the state machine I showed you earlier is exactly this one. If I go into it, you can see it starts with initialized, and then it progresses all the way through. The idea is that in a normal case like this one, it completely automatically finishes. So we automated it to a way that we don't need to do anything at all. At the end of 20 minutes, 30 minutes, it's reaching the state done. Yeah. So I'll just get it started. Auto release. The warnings we can also ignore because they are also false positives in this case. We manually check this and everything is fine. So auto release and go. All right, so now you can see that the first steps have already been taken. There was a ready for auto release pre-check that we made sure that all of these constraints that I was talking about are valid. One last check. The change logs for each of those releases in GitHub need to be ready and defined, which also happened. So all of that is done. At this point now, it merged already the core pull request. But what it currently needs to do, and that takes some time, is merging the project pull request. So we can see that it tries to resolve a conflict now. We know that projects have a composer log file, and the composer log file will be outdated every time you release something. So it's very normal that you have a conflict. As long as it's only this file, the tool will completely go and complete automatically this step, because it knows to resolve the conflict for the log file by using theirs, so the current master. And therefore, once it's done, it will continue merging also the project with a resolved conflict done. And at that point, we want to then transition into the splitting. So it will take those 5 modules and put them into the split repositories. That is a timeout here. So when this happens, we know that it takes up to 30 seconds before the split is completely finished. And that's why we are using a timeout-based event here. So in the background, cron jobs are just monitoring the timeouts. And when this 47 seconds is reached, this will actually trigger. And only if it is not split, it will go into another loop for another 47 seconds. And until, of course, the maximum of configured loops is reached, then it needs human intervention. And the human can actually then fast track it here by saying, yes, I confirm now. After too many runs, I checked and there was an issue and I fixed it, that we actually manually confirmed that the split is complete. And from there on, we continue with the validation. Then we start the release process. From there on, it can also be, again, something that we need to wait for, because if you have 100 modules to release and GitHub has an API rate limit, it's just something that can take up to some time. Once it's released, we are going to confirm it. The confirmation is basically checking if packages listed it properly. If packages doesn't have it yet, the next tool that we're running is Composer Update to actually make the project aware of the new modules, also the new versions that have just been released. If you do that too soon without packages knowing about it, it will not work. So the whole thing is just for fun. we want to make sure that packages has all the date. Then we confirm the update. Then we finalize a few things in our code, and then we're done. In the code itself, it looks a little bit like this. So we have the state machine, which has all these states. It has the transitions. And it has the events. And they build what we just saw as a graph. And when you change something here, the graph changes immediately with it. So it's basically real time when you develop a state machine. Usually when you change something, you would use another state. So when you do some fundamental change, you use release 02, because all the new items will automatically go to this new second process, and the items in the old one will continue and run in the old process. The state machine handler that I showed as a very basic one yesterday, here as a real implementation. So all of these actually are connections of the XML, also the graph, to actual code pieces in our CakePHP framework application, and the same for the conditions. So if we, for example, go into a command like merge command, you can see that for each of our release elements in a release group, if it's applying, and then we try to merge it. Otherwise, we don't do anything here, because that is part of a different job to check if the merging was complete. So we just abort. Yeah, so these are the small little pieces that we need in order to combine all those things. Any questions so far? So I'm pretty sure that resolve conflict is still running, yes. We can see the progress happening. We can also see the progress of this queue job in the background. So if we wanted to go to the backend, we can see the matrix overview, which shows us that a lot has been done. One is in merge pending, and the other is in project update pending. This one is the one we're talking about. This one is some error case from the past. I will have to look into why this state machine for this one is not fully done. So that's something to investigate. It should not happen usually, because you always want to go to a done state. We can also go to the queue. And here you will see that there is currently this job for composer update is running at 38% progress. And it's slowly progressing, continuing. When this is done, then as we said, it will trigger the state machine to resolve. We can look into that project resolve conflict. If we go into project resolve conflict task, then at the very end, it should have a, So once this is done, we just have a timeout for 1 second to have any leap issues gone. And then we trigger the state machine with the event confirm merge. And that will continue the rest of it automatically. So usually when you start a release process, you don't need to do anything. You just wait and let it finish. And when it's done, this last one reports back to our Slack channel and says, hey, the release has been done. And then I know, okay, cool, we can start the next one. In the future, there's more automation, of course, because you can already make the whole release plan automated. Once it's in the release plan, it can release itself already. But we still want to have a little bit of last, we call that the 4i principle, like some last check from someone independently over this code, just to make sure that there's really no human error anywhere involved. No, we have Mark's story for the core releases exactly. He is his own state machine, like a human state machine. So yeah, the ultimate one. But it's a good idea. And actually that is something that I thought before. That it's always the thing about resources, and time. And Yeah, but it's definitely something that someone, if interested, could look into and automate in general open source repository releasing. The tools are there. Yeah. The IDE is PHP Storm, together with the IDE helper to make sure that we have all of the IDE autocomplete available that we want to have. Okay, so while this is still taking some time to fully resolve itself, I think we're probably running out of time. Last questions before I give back the microphone. Okay, I guess that's it. Thank you, and yeah, enjoy the rest of the CakeFest.
Thank you, Mark. Okay, so we are running a little bit behind.